Welcome to this short tutorial that will go through solving and graphing a quadratic equation. Hopefully by the end of this video you'll have a better idea of how everything you've learned so far comes together. Once you have identified you are in fact working with a quadratic equation, then you want to check, is your equation in standard form? Standard form is ax squared plus bx plus c. In this case, we do not have all terms on one side of the equation, so we need to get it in standard form before we can start to find the solutions. To do that, we need to get all terms on one side by using inverse or opposite operations. The -9 can be moved to the other side by using the inverse, which would be adding 9 to both sides. Once you have all the terms on one side, set your equation equal to 0, and then we can begin to find the solutions. There are several different ways we can find the solutions, and it will depend on what type of equation you are given. For example, the complete the square method must only be used if a equals 1. It does in this case. The quadratic formula can be used for any type of equation that's quadratic in nature. The principle of square roots is one we didn't really spend much time on, but it is another option, and factoring, which you have spent a lot of time on. Factoring, we can find the solutions and use the zero product rule. Since the quadratic formula can be used for any quadratic equation, and that tends to be one of the most difficult for students, I will use that one to solve this quadratic equation. This is the quadratic formula, so you need to identify in your quadratic equation what a, b, and c are, and substitute those values in to be able to solve. In this equation, a equals 1, b equals a positive 20, and c equals a positive 9. So once we substitute those values in, we can simplify and solve. Here's what it looks like with the numbers in place. And don't forget your order of operations when you simplify. We need to perform the exponents first, then multiplication, and then subtraction to simplify the radicand. After simplifying the radicand, you should get the square root of 364. This is often a problem for students just trying to simplify the radical term itself. You might have to do a little playing around with some numbers. It is an even number. It is not a perfect square, but I'm sure we can find a perfect square to remove to simplify this. I played around with some numbers like 16 and 81, 36, different numbers that were perfect squares. None of those worked, but seeing as it is an even number, I tried 4, and 4 is a perfect square and also is a factor of 364. So I can remove that perfect square to continue simplifying. Once I remove my perfect square, I end up with -20 plus or minus 2 times the square root of 91 all over 2. This can be simplified further since every term in the numerator and every term in the denominator are divisible by 2. When we simplify this rational expression, we get two solutions, -10 plus the square root of 91 and -10 minus the square root of 91. These are exact solutions. 91 is not a perfect square root, which is why these are exact solutions. If you are asked in my math lab, if you're asked to approximate the solutions, that's when you can use a calculator. When you plug these values into your calculator using the correct order of operations, you should end up with two solutions, -0.46 and -19.54. Those are the solutions, also known as the roots of the quadratic equation. And if you're not familiar already, these are also the x-intercepts. Y will always equal 0, if you remember that from Math 116. These are 2 points that you can plot on your graph. And I will show you the graphing portion now. Now if you're graphing something like a decimal, it's not going to be exact, but as long as you get pretty close, here's what those 2 points would look like. The next thing you can do is determine whether the parabola opens up or down. We can do that very quickly by looking at A. A in the original equation in standard form was 1. It's positive. That means that the parabola will open up in the shape of a U. Keep that in mind when you are going to graph. So next we want to find the vertex, exactly where the minimum point is on this graph. I know it's a minimum because, as I just said, the parabola opens up. So there will be a lowest y value. Everything else will increase in a y value. Step 5, and close to finishing, we need to find the vertex using the formula negative b over 2a. Taking the values from the standard form quadratic equation, we get negative 20 over 2 times 1. Simplified is negative 20 over 2, which again can be simplified to negative 10. Now what we did is just find the x value of the vertex. We still have to find the y value, so that's our next step. Here's the original equation in standard form, and below that I substituted in negative 10 for x, and now we can solve. Don't forget your order of operations. Perform the exponents, and then perform the multiplication, and then we do addition and subtraction, same priority, reading left to right. After simplifying, we end up with a y value of negative 91. So now we have our vertex point as being negative 10, negative 91. And now you have the two x-intercepts and your vertex plotted. You can create your parabola now, and here's what it would look like with the vertex, the two y-intercepts, and drawing the parabola, which is symmetrical. Just on a side note, to connect another topic we were learning about is the line of symmetry, which is just the x value for the vertex. The line of symmetry cuts the parabola exactly in half, which makes it symmetrical. Hence the reason we call it the line of symmetry. So hopefully you have a better understanding now of how the pieces all fit together, and you're able to graph and solve quadratic functions or equations. And be sure to let me know if you have any other questions. I hope this helped. Good luck.